Yasmin Sarita, and the topic I'm going to be discussing are trees. Trees are a data structure that are used in programming language. In programming languages, I'm going to be talking about how to write them in Java. Um, all trees are made up of nodes, and a node is just like an object that holds some data. So this is an example of a tree over here. Each of these numbers represents a node, and the number is the data inside the node. The head of a tree is just the top node. So in this case, the head of the tree is a node that contains one. And children are another part of trees, and that's just nodes that are connected to another node. So the children of one is 2 and 3, and a child of 2 is 4 because it's connected to the top. And so I'm going to specifically be talking about binary trees, and that means each node can have up to 2 children, but it doesn't have to have 2 children. Like this is a binary tree and 2 only has 1 child, but it can have more children. Now there are 2 ways of writing and like using trees in Java, and one is with an array list. So I'm going to show you a class that uses an array list to store a tree. Okay, so this class is array binary tree, and it has, as an instance field, it has an array list, which is just contains the elements of the tree. And then this is the constructor which initializes the array. This method size just returns a number of elements in the tree. The add method just adds an element to the tree, and when we add an element to the tree, for in the array version of the tree, you can only add an element to the right of an existing element, or you can add it on the next row. So for 4, you'd have to add, if I wanted to add one, the 5 would have to go over there. Then this method gets the parent index if you give it the child index. And now I told you what a child is, but a parent is just, so like 1 would be the parent of 2 and 3. The next method gives you the child's index if you give it the parent index, and you can specify which child you want. There's a left child and right child. And the last method here is a way of traversing the tree. And I'm just going to go through each method and show you how they're implemented. So when I store the elements in the tree, the array it will just have the elements starting in the top row. It'll just have from left to right, so 1, and then the next row left, right, 2, 3, 4, 5. So it just goes like that. And this is the array, and then the indices would obviously start at 0 because all array indices start at 0. Okay, so then size would just return the number of elements. Would just return the size of the array because that's the same number of elements as the tree. The add method just has to add an element to the end of the array, because we saw we can only add 1 to the right of the existing element. And for the next method, there's a formula you can use to determine the parent index if you have the child's index. So for instance, if I try it with 4, the index of 4 is 3, so I would do 3 plus 1 divided by 2 minus 1. So this is equal to 4 divided by 2, which is 2 minus 1, and that equals 1. And then at index 1 you have 2, which is the parent of 4. And you can see that this formula would be the same even if I tried 5, because the index of 5 is 4. So I'd have 4 plus 1 divided by 2 minus 1. And these are integers, so if you have 5 divided by 2, it just evaluates to 2. And then 2 minus 1, you'd get 1 again. And that's this, because since they both have the same parent. For the next method, if I'm getting the child's index, suppose I give the parent index of 2, so I have 1 is the parent index, and then this boolean just says if you want the left child or the right child. So if I want the left child, I'll say true, so these are the parameters to the method. And then if I use this formula, you have 2 times 1 plus, and then this expression just means that if the boolean is true, then it evaluates to 1. If it's false, it evaluates to 2. So in this case, it's true. So it'll be 1, and this equals 3, and the index 3 is the index of element 4, which is why the left child of 2 is 4. And now the last method, as I said, it's a way of traversing the tree. So it's called level order, which means you start at the top level, which is this level, and then you go from left to right. So you do 1, 2, 3, will be 4, 5. And you can see that's the same order as the array, so this method just returns the array. Now, there is another way to represent a tree, and that is using the tree node class. So now I'm going to show you the tree node class. Okay. So this is a simple class. You have each of these nodes is one tree node, and then the instance field value, it's type E, which means it can be anything. So that means the value of this node is 1, the value of this node is 2. The value just is whatever data is stored inside the node. And then it also has instance fields for the left and right node, left and right child. So for 1, left would be this node and the right would be this node. And if you don't have a left or right child, these instance fields would just be null. And now I'm going to show you a class that uses this the tree node class to create a tree. So this class is called a linked binary tree, and it has two instance fields, the root and the size. So you only need to store the root because all of the nodes are connected to each other. So if you have the root, it's connected to the rest of the tree. And then this is the constructor which initializes it. The size just returns the size. And this is the add method. In this case, the add method is abstract because in a general binary tree, you don't know where you want to add the element. So any subclass of linked binary tree would have to implement this method. But right now, I have it there, but I don't have any code for it. And now these methods are all ways of traversing the tree, and there are three ways. There's in order, pre-order, and post-order, but I'm going to focus on in order in this video. So now I'm just going to describe the algorithm that this method implements. So if I have a more complicated tree like this, and I want to traverse it in order, the rule for in order traversals is you go to the left, then you go to the node, and then you go to the right. So I'll explain what this means. You can think of, so if one is the head, it shouldn't be the head. If one is the head, then the left child is, you can think of it as the head of the left subtree. So this is the left subtree. And then the right child is the head of the right subtree, because it's the top of the right part of the tree. And so now, basically in order is telling you to retrieve all the elements on the left subtree, then retrieve the head, and then retrieve all the elements in the right subtree. So I'm just going to go through the in order traversal of this tree to show you how you do that. So you start with the left, so then you would start with this subtree, 2 and 4, and then again you start with the left. So you go, so 4 is the first element, you retrieve. And then since there's nothing else here, you would go to the head, and the head is 2, ahead of this subtree. And now since I finished this, since there's nothing to the right of 2, I finished this subtree. So now I go to the head of the entire tree. So then I'll go to 1. Okay, and now I have to go to the right subtree. So then for this subtree, you again go left, head, and then right. So left, we just have 5, and then the head is 3. And now for the right, for this, so now we're on this subtree, which is the right subtree of this. So then we again go to the left, which you start at 7, and then 7 is also the head of its own subtree, But since 7 doesn't have anything to the left of it, we'll put the head of that subtree, and then we go to the right, which is 8. And then we go back up. Since we finished the subtree over here, we'll go back to this one, which is 6. And now 6 has nothing to the right, so we're done. So that is the in-order traversal of this tree. And now this code, basically, since this algorithm is recursive, this method has to run itself in the method. So now this is the public method, but then I have another private method that's recursive. So the public method just runs my private method, starting with the root. And then basically it just visits the node and sees if it's null. If it's null, then it returns null. And basically, so that's the base case, and that means that we're at the end of the tree. And then otherwise it creates an array list, and it goes to the left of the tree. It runs this method again on the left subtree, and then it adds all of the elements in the left subtree to this array list, and then it adds the head to this array list, and the head is just what you pass in as a parameter, and then it adds all the elements of the right subtree. So that's what we were doing over here, and then it just returns this array list. So when it's done, it'll have a complete array list of all of the elements in a specific order.